let's go ahead and start first by discussing the answers to the quiz on experimental design and benthic sampling methods that we had last meeting. So I think it has a lot of math, which I think made it a little bit more challenging for most people, especially since it requires a good understanding of, or a good memory of basic formula related to geometry. So the first is to compute for the coral cover of the sample shown on screen. So letter A asks you to use the intersection method. So if you're using the intersection method, please note that you want to count the number of intersections in the quadrat that lie on top of the corals. So here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you have 13 intersections falling on top of the coral divided by 36. And this one, bakit 36? Kasi merong 36 na total intersection points. So you have 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. 6 times 6, 36. So that's why 13 divided by 36, which will equate to 0.36, convert to percentage, we have 36%. Letter B asks you to use the grid method. So for the grid method, this time, you count the number of grids, so these are the squares, that have at least 50% of corals under them. So here, we count 1, 2, 3, 4, 5, 6, 7. Bakit hindi to counted? Kasi less than 50. Ito hindi counted kasi less than 50. Same for this one. So, tiles 7 divided by 25, that's about 0.28. So that's 28%. Now, things get a little bit challenging with letter C because this one asks you to compute for the absolute error using the intersection method. If you remember from our previous exercise, the absolute error is the difference between the true value and your approximation of the value. So the intersection method gives us the approximation of 36%. In order for us to get the absolute error, we need to have the true value. So this can be computed for getting the area of the coral times the number of corals and then divided by our reef area. So the area of the coral, which is circular, can be computed by the formula pi r squared. So we have a diameter of 1. We divide that into 2 kasi the radius is half the diameter. So 3.14 times 0.5 times 0.5 times 7. So that's the area of the corals and the number of corals. So bakit times 7? Kasi meron tayong 7 na corals. 1, 2, 3, 4, 5, 6, 7. So pi r squared times 7 all divided by 25 will get us a value of 0.2198, which can be rounded up to 22%. So for the intersection method, wherein we approximated the coral cover to be 36%, 22 minus 36 equals 14%. And then for letter D, since we already have the true value, all we need to do to get the absolute error using the grid method is to subtract 28 from 22, which will get us an absolute error of 6%. So that's for item 1. Do we have any questions or points of clarification for item 1? Now would be the best time to ask. Okay, could you give me a thumbs up reaction if you don't have any questions regarding item number 1? Okay, great. So now let's move forward to question number 2. So this one, you have data collected using the transect quadrat method in a reef with only one species. So you're supposed to compute for percent coral cover of the entire reef and then to show solutions. So you have 3 transects, which means you have 3 replicates. Transect 1 has 2 quadrats, both with readings of 0. So 0 plus 0 divided by 2 is 0%. That's the value for replicate 1. For transect 2, you have 3 quadrats with readings of 0, 10, and 5. So 0 plus 10 plus 5 is 15, divided by 3 would result to 5%. While transect number 3 only has 1 quadrat, which is 5%. 5 divided by 1 is 5%. So now we have the averages of the 3 replicates. But to get the percent coral cover of the reef, we need to average our 3 replicates. So we do that by adding 0, 5, and 5, all divided by 3. So that's 10 divided by 3, which will give us 3.33%. Okay, so that's how you compute for the average of transect quadrat. You average the averages. Any questions for item number 2? Could you give me a heart reaction if you don't have any questions regarding item number 2? Okay, so let's move forward to question number 3. So when we add subsamples, which is affected more, accuracy or precision? So explain your answer briefly. So this is a topic that touches on a lesson that you might have encountered in lecture, but it's definitely present in Hurlburt. So if you were able to read Hurlburt, which I hope you have, because your long exam in lecture is gonna be on Thursday, and also your oral presentation in lab, no? So you have to be so familiar with Hurlburt already. But anyway, the answer here is precision, because what subsamples do is they balance out the natural variation that you can find even within each replicate. So this variation is no longer represented in the actual mean of replicates, and so it has the tendency to increase precision. Kung baga, kung meron kang replicates na sobrang varied, yung subsamples na yun ay neutralize or binabalance out yung variations. Kaya tumataas ang precision. Okay? Any questions or points of clarification regarding item number 3? Could you give me an open mouth, the wow reaction, if you don't have any questions regarding item 3? Okay, good. Next, for question 4, another item where our knowledge of pi r squared would be very useful. So for item 4, what is the true percent cover of species A? So species A is the smallest coral. It has a radius of 0.8 centimeters. So to get the total area covered of species A, you get pi r squared times 9 because you have 9 individuals of species A. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So pi r squared, 3.1416 times 0.8 times 0.8 times 9 will give you a value of about 18 square centimeters. And then you divide 18 square centimeters with the area of the reef, which is 550.45. So 18 divided by 550.45 is about 0.0329, or about 3.29%, or 3.3%, or 3%. So that's the answer for question 4. Before I open it up to questions, I'll go through the connected questions first. Kasi yung question 5 is related. What is the true total area covered of species B? So since it's just total area covered, you don't need to get the percent. It's just pi r squared times number of individuals. So B is bigger than A. Its radius is 1.6. So 3.1416 times 1.6 times 1.6 times 6. Because let's count the individuals of species B. 1, 2, 3, 4, 5, 6. So that's why it'll give you a value of 48.2304 square centimeters or 48.2 or 48 square centimeters. And then for item number 6, what is the true total percent coral cover of species C? So species C has a radius of 2.9 centimeters. So pi r squared times 4, because we only have 4 of these corals, 1, 2, 3, and 4, which will give you 105.63 square centimeters. You divide that with the total area, which is 550.45, to give you a value of 19.19% or 19.2% or just 19%. So that's how you do your computations for items 4, 5, 6. Any questions regarding items 4, 5, and 6? Okay, could you give me a ta-da reaction if you don't have any questions about item 6? Okay. So one final question for the quiz before we proceed to our consultation. Based on your computations, which of the following statement is are false? So let's look at statements A, C, and D. Coral species B has a lower total area than C. Let's look at total area of C, 105. Total area of B is 48. So definitely statement A is true. Let's look at coral species C. It's the fewest but has the highest cover. So coral species C only has 4 individuals, but its cover is 105 or 19%. B is more in number, but it's 48 square centimeters. And A has the highest number, but has the lowest cover at 18 square centimeters. So that makes C true as well, because C is fewest, but has the highest cover. And then for D, the size and number of coral species would help determine the percent cover. We can also see that it's true because the size affects the area and the number defines how much of the reef is covered by that coral. So letter D is true as well. However, for item B, the randomization technique can be determined based on the given data. For all we know, you did haphazard randomization. For all we know, you intentionally designed the reef to be like that, or you intentionally designed your sampling method. So sadly, the randomization technique cannot be determined based on the information that we have. At the end of the day, all the information that we can get is the size of each coral, the cover that they are covering, and also their percent cover. Okay? So any questions about item number 7? Can you give me an old school thumbs up reaction if you don't have any questions about item number 7? Okie dokie. Okay, so just like last time, I will be showing you the results of your quiz after during the individual assessment for exercise 3, just to make sure you know if there are any issues or things that can be corrected from the quiz. But right now, we will be focusing on consultations for exercise 3. Now, to make sure that you are progressing well with your analysis, huwag na tayong ma-shy sa isa't isa. Let me just make sure that screen sharing is allowed. Okay. So just like in our previous consultations, I will ask you to share screen a particular aspect of your data for exercise 3. And then I will take note and give comments after all groups have shown me what they have. So I'm assuming everybody has complete data, but just to make sure, sige, let's start with group 1. Um, group 1, who can share screen for me to see your data? Um,
Miss, I'll be the one to share screen po.
okay, thank you.
Give me a moment lang, miss.
No problem. Okay, for the others, I hope you're also preparing who will share screen for you so that we can proceed as efficiently as possible. So raw data po muna tayo. Okay, can you scroll down so I can see all replicates?
Ito po yung small quadrat.
Okay, can you select letter column I, row 24?
Sorry, wait.
No problem. Row 24. There you
24.
go. Okay, just wanted to see the formula. Okay, thank you for that. Can you show me the raw data for large quadrat?
Here po.
Okay, thank you. Yung 22 na row, is that blank or zero?
I'm not sure po, pero kasi, meron parang kasing formula ata we plan to put there kasi medyo nagugulan ata when our groupmate was doing it. So he's trying to figure out what data to put in there.
Um, can you explain yung group mate?
Wait,
Because I don't think you can proceed to statistics and all the others if you have blank data sets. So is this supposed to be zero or something else? Please explain.
Good afternoon po, Doc. Akin po yung sa May 22 and I think hindi lang po nalagay ng mga naglalagay sa data po. And follow up po namin yun regarding po. Yun po yung pinatanong ko po sa inyo last time na may 22 na lang po yung sa grid.
Okay, pero yung formula yung babaguhin, hindi yung raw
Yes po,
input.
yes po. Inaayos pa lang din po yung sa formula and pa-update ko na lang din po if ever, Doc. Thank you po.
Okay. Can I see transect quadrat? Okay, do you have a version where the subsamples are shown? Because these are only replicates.
okay, hold on. Let me. Yeah. Miss, I think ano po yung subsamples, the one who did the transect did it individually, kaya it's not in our shared sheets, I think.
Well, in order for me to make sure that your computations here are correct, I will need to see the subsamples, particularly since it's a little dubious na parang ang in-average is yung intersection points and not the cover. Kasi i-convert nyo lang siya to percent cover. Yeah, kasi i-convert nyo na siya agad sa percent cover. So, dapat walang average intersection points per individual. So, it's a little dubious, and I'm a little worried kung tama ito. So, if you're not able to show me the subsamples for your final submission, actually, ngayon pa lang meron na kayong konting deduction, pero sa final submission nyo, mas malaki pa if I don't get to see the subsamples, okay?
Sige po, we'll follow up on our groupmate on that kasi she updated us po na nagawa niya yung subsamples pero I don't think nalagay dito sa sheets.
Okay. Can I see the raw data for line intersect transect?
Here po.
Okay, thank you for that. Sige. We'll now move forward to another group. Thank you.
Thank you.
Okay. Group 2. Group 1, kindly stop screen sharing so that group 2 can share screen. Okay, group 2, who will be sharing the screen for you? Sige, ganito na lang. Pag walang sumagot sa akin within 10 seconds, na sabihin ko na group nyo na yung magpa-present, isi-zero ko na lang kayo for that part ha, because I'm assuming either hindi kayo ready or hindi kayo nakikinig. So, ulitin natin. Group 2, who will be screen sharing for your team?
Good afternoon po, Doc. I can screen share po.
Okay, sige. Pumasok pa siya sa 8 seconds. Muntik na kayo doon, group 2. Okay, so please show me the raw data for small quadrat. Okay, can you go to column L, row 14? Column L, row 14. Okay. Why is there no formula? Sige, column L, row 15. That's just one row down. Column L, row 15. Can you please click it so I can see the formula there? Column L po. How did you compute for 32 if there is no formula here?
Hello po, Miss.
Mhm.
Hold on. That's SQ, right? We compute. I think we copy pasted this as values lang. Pero
From which area?
yung percent cover po here, but there's a oh from a separate worksheet, but we computed it through in these separate boxes. Is it seen po? Wait lang. Nikki, could you scroll a bit to the pinaka-left?
Hello, Pe. I'm sharing my whole screen, so I'm a bit confused if ano lang yung nakikita nyo.
Okay lang. Sige, thank you.
Okay.
We got 32 po from replicate 11. Sorry, na-exit po ako saglit. Ay, no. I mean replicate 12. Wait, ano po yung sagot niyo po ulit? Sorry. Ay, yung question niyo po, miss.
How did you compute for 32%?
Okay, 32. Because in the separate worksheet, mali lang po yung yung na copy-paste kasi na values lang. So, yung 32 was, we got it from getting the percent cover of A,
Which is
and
computed how?
which is computed by the number of grids, which is 8, tapos over 25 times 100.
Okay, so I think it would be better if the formula are indicated in the sheets because it helps me verify if your computation is correct. If you just copy paste numbers, it it makes it a static sheet na kung meron kayong minor changes and so on, mas mahihirapan kayo mag-adjust. One of the points of having an Excel sheet with live formula allows you to have faster adjustments when needed. So please make sure in your final submission, the formula are incorporated in the values that I can check. Okay?
Okay, thank you po.
I'm assuming your large quadrat is the same also. Can you click that? Column L, row 5. Okay, thank you. Can I see the transect quadrat sheet? Okay, at least I can see the subsamples. Can you go to, sorry, don't scroll too fast. Can you go to column J, row 48? Okay. Row 48. Can you click it, please? Thank you. So, wala ring formula dito.
Miss, meron po sa some parts of that. Yung sa mga zeros lang po yung ano.
O
Pero,
sige, yung number 20, pakiclick. Yung column K, row 47. That's just one step up and a little bit to the right. Column K, row 47. Pakiclick so I can see the formula.
This one po.
Okay, there you go. Okay, thank you for that. Finally, LIT. Okay, can you go to column L again, maybe row 5? Okay, sige. Thank you so much. You can now stop sharing group 3. Group 2, sorry. Group 3, who will be sharing for the team?
Hello po, Miss. I'll be sharing.
Okay, thank you. Okay, let's start with small quadrat. Okay, can you click on column L, row 5? Okay, thank you for that. Next, large quadrat, please. Okay, column K, row 6. Okay, thank you for that. Transit quadrat, please. Okay, good. Can you go to column AC, row 7? Nice. Okay, good. LIT, please. Okay, can you go to column M, row 10? Okay, great. Thank you so much. Good job, group 3. You can now stop sharing. Group 4, who will be sharing on your behalf?
I'll be sharing this.
Okay, thank you. Okay, thank you for that. Let's start with the small quadrat. Okay. Can you, oh, okay. So, okay, your layout. Okay, I can see your formula, so that's good. Large quadrat, please. Okay, but can you scroll up? Can you click on, oh, okay, I can see it too. Okay, that's fine. Transect quadrat, please. Okay, scroll up. Can you go to column L, row 3? There you go. Okay, good. Thank you. LIT. Column H, row 9. Okay, thank you so much. You can now stop sharing, group 4. Let's now move forward to looking at the statistics of the data. So let's go back to group 1. So group 1, will it be the same person who's gonna share?
Yes po. I'll be sharing screen for group 1 for the rest of the
Okay. Can I look at the statistics for your group? Okay, can you tell me what statistics you used? Group 1?
We use descriptive statistics and ANOVA single factor po.
ANOVA single factor. Groups A, B, C, A, B, C. Okay. Sige, mamaya na ako magko-comment. Thank you for that. Sige, you can stop sharing for now. I'm curious to see from the other groups. Sige, thank you, group 1. Please stop sharing. Group 2? Will the same person be sharing?
Yes po, miss.
Okay, can I see your statistics, please? Okay, descriptive stats. Okay, that's fine. Your ANOVA. I'm assuming it's ANOVA because there's a sheet that says ANOVA. Okay, where is the ANOVA? Okay. Okay, ANOVA. Did you use ANOVA single factor also?
Yes po, with the replication.
Okay, very good. Thank you for that. Group 2, you can now stop sharing, assuming you did the same thing naman across the board. Group 3, can I see your statistics, please? Okay. So, you guys did ANOVA 2-factor with replication? Please confirm. Yes or no?
Yes po, miss.
Okay. Can you scroll down a little bit? Okay. Thank you for that, group 3. Let's now move on to group 4.
Yes, here po, Miss Yu.
That's your descriptive.
Descriptive.
Okay. How about your ANOVA?
Response
Okay.
is for sa kanila.
I'm
Standard.
assuming you did single factor ANOVA also?
Yes, miss.
Okay. Okay, thank you for that. Group 4. Okay, you can stop sharing now. Okay, so for statistics, you're supposed to only do single factor ANOVA. You don't have any blocks for this exercise. So there is no need to do a 2-factor ANOVA without replication. So the best thing for you to do is to do a single factor ANOVA with replication. But group 1, the comparison that you're doing is across species, not across methods, which is the wrong type of comparison. You're not checking for the difference in coral cover of species A, B, and C in total. What you're supposed to be doing is to check if the accuracy and precision of the 4 benthic sampling methods are the same or different. So gusto mong malaman kung anong method yung mas accurate. So ang dapat na kino-compare nyo sa ANOVA nyo would be the 4 methods. What I've seen in your statistics, however, is yung species A, B, at C yung na-compare. So you need to adjust your columns and rows to make sure that you are comparing the right parameter. Is this noted, Group 1?
Yes po,
Yes
Miss.
po, Doc. Thank you
Okay.
po.
Sure. Groups 2 and 4, so far from what I've seen, you did it correctly. Group 3, just shift to a single factor ANOVA and make sure that you're comparing the methods, not the species. Okay? Is this noted, Group 3?
Yes po, Miss. Doc.
Okay, great. So now let's move on to the graph. So Group 1, can you flash us your graph, please? Okay. Species A, B, C. Small quadrat, large quadrat, transect quadrat. Bakit yung LIT wala siyang value? I think you might want to adjust.
Maliit yung sa, what do you call this, sa line intersect po, medyo mababa kasi yung values.
Can I
Kaya,
see the results? The summary
wait.
for LIT? Are you sure? Because if it is, then you might have done it the wrong way.
This is the stats po for line intersect.
It's possible na hindi nila na-convert yan to percent. Instead of being read as 0.147, that might be referring to 14.7. Kasi if that's not percent, that means it's that's too small. So I think there's something wrong with your computations for LIT. You might need to convert it to percentage before doing the descriptive statistics.
Yung percentage po for line transect po, if we have it here.
So,
I
hindi
think
ba kayo, so for example, the average of all of that, hindi ba kayo nagtataka, lahat yan 13, 14, 20, tas biglang naging 0.14 siya? So, hindi nyo na-convert to percentage yung baba.
I see, sige. Sige po, we'll confirm po with my group mates. Pero, ayun, I think something happened. Naging 15%.
But
Yeah,
Miss,
because it
when
was,
we did,
Something happened.
Miss, when we did the descriptive statistics po, yung ginamit po naming data, yung naka-percentage na po.
i-recheck nyo lang yung formula or yung layout ng bawat isa. Kasi, yun nga, I think tama naman yung data nyo. Mali lang yung pagkaka-present sa kanya dun sa descriptive. Oo.
Okay po.
I tried double clicking na po. Na parang bigla lang nag-change to percents. Kaya, to 15, 16, 8, 39.
Yeah, so like I said, wala namang problema yung data nyo. Kaso hindi kasi
sige.
kayo nagiging careful sa formatting. So kanina, di ba, pinagtatanggol mo, sobrang baba po ng value ng LIT, pero mali lang pala yung format. Di sayang, muntik ng maling-mali yung presentation nyo, di ba? Hindi nyo lang pala na-convert sa tamang format. So just be careful with that, Group 1, okay?
Sige po, thank you po, Miss.
Okay. Group 2, can I see your graph, please? Species A, B, C, and total. Okay. Sige, thank you for that. Group 2, let's now see from... sorry, may I know what error bars you used? What value? Yung naka-mute, Shina? Anong value yung ginamit niyo for error bar?
Standard error po, Miss.
Standard error. Okay. Group 1, sorry, hindi ko natanong kanina. Anong error bar value yung ginamit niyo?
Yung error bars po,
Standard
yung
error
standard
po.
error.
Okay, standard error. Thank you. Group 3, can I see your graph, please? Okay. May I know what value you used for your error bar?
Performance confidence interval po.
Confidence interval. Thank you for that. Next, group 4, can I see your graph, please?
This separate, you made a separate graph for total tsaka per species.
Okay, sige. I'll just show me both, I guess. Sige, yung isa muna. This is total. Okay. And
Yes.
then per species, please. I'm assuming yung red dotted line yung true value. Okay.
Yes. Confidence interval. Yeah.
And you used confidence interval. Okay, thank you for that. Okay, sige, you can now stop sharing. So, in terms of the graphs that you've created, generally speaking, tama naman yung mga gawa nyo, except for the true value lines. So for group 1, for example, it's missing. For groups 2 and 3, it's wrong. And then for group 4, okay siya. Actually, sa group 4, good idea. Just to give you an idea on how you can put the true value line, these are some examples of graphs created by previous batches. So you have to create separate true value lines per species and for total. So at least tama na magkakasama yung species A, B, C across methods and then total. As for your error bars, both standard error and confidence intervals are useful for this exercise. Kasi pareho naman silang inferential, and since we have 30 replicates, both are useful. Ang confidence interval lang ay meron siyang additional benefit na it can give you, if unknown yung true value, it can give you a rough idea on what the unknown true value is. Pero in this case, since the true value is known, you can compute for it, then standard error will also be useful. Okay? Group 4, advice ko lang sa graph para hindi na kayo mahirapan sa discussion or hindi kayo maubusan ng time during your presentation. Isama nyo na rin yung total sa same na graph para at least sama-sama na silang lahat. Okay? Is this
Yes,
noted, group 4?
yes.
Okay,
Yes.
good. Okay, so now let's go through the debunking. I won't need you to do the complete debunking. I just need to see the text and the information that you are using to proceed with the debunking. So let's start with group 1 first. Group 1, let's go through debunking.
Doc, wait ko lang po kay Shaina.
Okay.
Baka po may pe-present lang din po. Ayan po.
Okay. So, which visual aid will you use for the debunking?
Miss, I'm basing it on the graph po. So, yung sa graph, since wala pang true value line, hindi pa ako makakadebunk. Pero sa precision po, yung, ano yun, transect quadrant, yung malaking error. So, what I perceived with that is, it's less precise. So, I'm using the standard error po for the precision. Pero since wala pang true value line, so I cannot fully debunk it po. Sadly.
Okay, anything else you'd like to add, group 1?
Doc, wait lang po, sabihan ka lang din po kay Shaina na i-present po yung finalized hypothesis na formulate or yung pinili po between the formulated ones.
Okay.
I actually have it on a Canva, the hypothesis.
Yes, then
Wait.
please show us.
This one. We're making the PowerPoint now kasi
Less
kaya we're
accurate,
using this.
smaller coverage. Okay. Yeah, those hypothesis pairs will work.
Yes po. And follow up na lang din po namin if ever man po. Basta po matapos na po yung graph and maayos po yung data.
Okay.
So we can start na rin po. Thank you po.
Okay, thank you, Group 1. Next, let's hear from Group 2. Okay, let me first see your hypothesis statements with larger, not yield. Better kung ang partnering ng hypothesis nyo Group 2 is benthic sampling methods with larger coverage area will yield the highest levels of accuracy. And then yung H1B, benthic sampling methods with smaller area coverage will yield the highest levels of accuracy. And then ganun din for precision. Benthic sampling methods with smaller area coverage will yield highest levels of precision. And then H2B should be benthic sampling methods with larger area coverage will yield the highest level of precision. Okay. Okay, but that's okay. And then you have your ranking. Okay. Anything else you'd like to add apart from the text shown on screen? Nakamute po kayo if you're saying something, Group 2, ha? Okay, so I'm assuming you don't have anything else to add. Again, thank you for that, Group 2. Let's hear from Group 3 then. Okay, Group 3, please share with us information regarding your debunking. Yeah, I can see your graph right now. Do you want to say something about it that's useful, or do you want to show me your hypothesis first?
Mika, can you go to the hypothesis tab? Okay. So, so these are the hypotheses that we highlighted, Doc, based on the um charts that we did earlier. Mika, can you go to the descriptive charts? We based it from this bar graph.
Okay.
So we found out that LIP and Transec are more accurate and precise based from these figures.
Okay. Because of their closeness to the true value line?
Exactly, yes.
Okay. Anything else?
For the
That
precision, for the precision po, we're yet to base it. Kasi we're yet to debunk it, but we'll present it po on Thursday po.
Okay. So, okay. Thank you for that. Let's now hear from Group 4.
Here po this. The first one's precision, second is
Okay, let me just check. With more subsamples. Okay, similar suggestion to Group 2. To make your debunking a little bit more efficient, na 2 statements lang instead of 4. Instead of 4 per feature. Yung H1A niya, di ba, methods with more subsamples will be more precise. Instead of methods with more subsamples will not be more precise. H1B would be better if you use methods with less subsamples will be more precise. And then the same recommendation for H2A and H2B. H2A methods that measure a continuous variable will be more accurate. And then H2B methods that do not measure a continuous variable will be more accurate. Is this clear, group 4?
Clear for us.
Okay. And then, so you have hypothesized and actual ranking. Anything else you'd like to add apart from the information on the screen?
We call this a precision tool. We
Mm-hmm.
just did it earlier, but we did like we call this extra inferential stats about precision living test, but we have yet to interpret it properly. Sa
Okay.
actual presentation, we kami find some interpretation.
Okay. Sige, thank you for that. Okay, you can now stop sharing, group 4. Okay, so when it comes to the debunking, I'm at least happy to see that you have your hypotheses. They're scientific hypotheses and no longer predictions. But one major red flag across all 4 groups, when you're doing the debunking for accuracy, you have to mention the presence or absence of significant differences first. Everybody did not mention it. Even though some of you had rankings, others did not. Some mentioned closeness to the true value line. Again, what's more important than the ranking, or what will eventually affect the ranking, would be the presence or absence of significant differences. If there is no significant difference, then your benthic sampling methods have equal levels of accuracy. But if significant differences are found, then you can say that one or more of the methods is more accurate compared to the other. Is that clear, everyone? Thumbs up if that's clear and noted. Okay, let's not make that mistake here, ha? Sayang. Okay, and then for precision, there is a statistic that you can use to check for significant differences in precision. But if you do not know how to do that, that's fine. You can just compare the lengths of your error bar. So at least the comparison for precision is a little bit more straightforward. Okay, so make sure that when you're debunking for accuracy, you mention the presence or absence of significant differences first. Okay, so yeah, I think more or less those are the things I need from you. I'm happy that majority of the work that needs to be done is done. And I'm looking forward to your the Ecology PLC, sorry, correction. The Ecology PLC is looking forward to your presentations this coming Thursday. So, and also, we wish you all the best for your upcoming long exam. Okay. We will be closing our Zoom call now. But final call for any questions or points of clarification, especially in preparation for Thursday. Okay, if none, then thank you.
Sorry,
Yes,
this
go ahead, go ahead.
after the presentation, will there also be individual Q&A again like last time?
Yes, I would like to confirm that just like last time, there will be individual Q&A for exercise number 3. The individual Q&A, just like before, pwede niyong dalhin yung data nyo. But I also strongly recommend that, well, technically, kung nandun naman yung Excel nyo, pwede nyo gamitin yung Excel if you need to do some quick computations for the question that I will ask you. Pero if you're more comfortable using a SciCal, you can also bring a scientific calculator. But
Okay,
otherwise,
thanks.
yun nga, you can bring your gadget. Pero kasi yung mga phone yung dala, baka mas mahirap mag-compute sa Google Sheets, baka mas madali mag-compute using SciCal. Pero kung may dala kayong tablet or laptop, you can use your Excel sheet for computations. Okay, anything else? Okie dokie. So if none, thank you so much. I appreciate the effort. Good progress, everybody. See you on Thursday. Bye-bye. Thank you.
Thank you po.
Thank you po, Doc.
Thank you.